Okay, so the reason why I've given you a chance to do this is because there's this obvious mistake that students make, and I'm going to go through that now. Okay, so what we need to do though is the one thing that we cannot be doing is eliminating solutions. What I'm going to say is that 2 cos of x is equal to root 3 cos of x over sine of x. No. Oh, whoops. Okay, so one sec. So I haven't. Where? Oh my God. Where is it? Okay, we're ready to go again. Okay, this is what you should have. This is what a lot of students do. But what they do is a mistake, because then they go ahead and they just go, oh yeah, they cancel out nicely. And that's can I get a show of hands how many students did that? Come on, be honest. There was a lot of you. Like, there's more of you. Did you do that, Luke?
I did it first, and I was like, no,
you can't do that. Thank you. All right. So what we can say is, don't ever do this for trig equations. What you must do is get it all on one side. 2 cos of x minus root 3 cos of x over sine of x is equal to 0. And of course now, rather than cancelling out, given the fact that 0 is like a solution, you're getting rid of solutions, so you can't just do that. And that's for solving equations. That's the most important thing I want to stress to you. You can't do that. So what do? We now take out cos of x as a common factor. And then we say that 2 cos of x minus root 3 on sine of x is equal to 0. Are we following me so far? Good. Okay. Now, of course, I therefore, using null factor law, can say that cos of x is equal to 0, or 2 minus root 3 on sine of x is equal to 0. Now, of course, this is an important step. Getting to there is probably going to give you a mark. Finding the other solutions is going to give you the other 2 marks. A number of students, since they'd made that mistake before and things, and probably would have got, a lot of students that knew what they're doing would have at least got a mark. But the thing is, it is not telling us over a certain domain. It says find all real solutions. That was the trick to this question, which meant that it was so poorly done. Did you have a question, Nikita?
Can you just times both sides right there?
What's that?
Can you times both sides right there?
Nah. It's just not going to get you anywhere. Okay. So, you can, but you're just creating more work for yourself. So what we need to do then is we need to consider, where is cos x 0? Cos x is 0 is pi on 2. And what? Negative pi on 2. And 3 pi on 2. So therefore, can't we just say that if I'm multiplying, I could just say that this is... therefore, cos of x is 0 when x is equal to... Couldn't I just say x is equal to pi n on 2? Such that n is... What is it? Can it be positive and negative?
No, that doesn't work, because if it's 2 pi and 2, that's pi.
Ah, good. So what are we doing then? Thank you. Pi on 2 plus n pi. They're very good. Okay. So pi on 2 plus... You can do plus or minus, and you can have positive integers, but we're going to say pi on 2 plus n pi, such that n is the element of integers, which means that we're looking at positive and negative numbers. So in other words, negative 1, negative 2, negative 3, 1, 2, 3, etc., etc. Does that make sense? That is one set of solutions. That's probably going to give you the 1 mark, perhaps. But now what we need to consider is this side here. Now, of course, you wouldn't do working like this. I'm just showing you, but of course, you would have it more logically set out. But what we can say is that 2 is equal to root 3 on sine of x. And we can say that sine of x is equal to root 3 on 2. We need to go back to the... there's actually 2 solutions where sine of x is equal to root 3 on 2, because our cast diagram, sine is positive in both the first and the second quadrant. So if it's positive in both the first and second quadrant, to find all real solutions, then what do we need to add to each of these values? We need to add and subtract any value of 2 pi. So we need to just go around and find the same point. So therefore we can say that x is equal to, where's root 3 on 2? Pi on 3. So therefore x is equal to pi on 3. And what else is it? 2 pi on 3. But we need to consider all of the real solutions. So therefore x is equal to pi on 3 plus or minus, or we can just say plus, is it pi or 2n pi? What do you think? 2n pi and 2 pi, x is equal to 2 pi on 3 plus 2n pi, and you don't forget you have to say that n is the element of integers, positive or negative integers. So, our answer, we have 3 general solutions. 1, 2, and 3. Now, what you could have done, you could have actually said that maybe we could have had this over 2, if you like, which means that this is 2, and you could have done it that way. But at the end of the day, something that is the same thing. Let's have a look at the examiner report, because this was an absolute schmozzle. How do I... Oh, I'm going to pause the video and find it, because... Okay, so first of all it says other equivalent answers were accepted, but this question was not well done. The majority of students losing the cosine term entirely. Isn't that what I got you guys to make that mistake for yourself? Okay, because you cannot do that. Cancelling it from both sides of the equation. Students should be cautioned regularly about the danger of using cancellation of variable terms as a simplifying technique. Because cos of x equals 0 is like a solution, you cannot just eliminate that. Of the students who found general solutions to the sine part, quite a few wrote the general solution incorrect. So that's very understandable. It was not done very well, a lot of the time because of the notation that students were using as well. But interestingly enough, like the students that were getting their mid, 40 plus in specialist were getting the 3 marks for that, or perhaps 2 marks. But a lot of students, 86% of students got 0 or 1 mark. So it was such a poorly done question. Now that's solving trig equations. Now we've done a really tough one. All right, so for this one, good old triangle method is the best way, in my opinion, to do this question. I can draw a triangle, and I know that let's just forget about the positives and negatives for the time being. But my x triangle, where the opposite side is 1 and my hypotenuse is 5, is this angle here, 1 squared plus something. Is this root 24, which is 2 root 6? Yes? Okay, so I've got 2 root 6. So therefore cot of x is equal to cos of x over sine of x, or 1 on tan of x. 1 on tan of x is, so 1 over 2 root 6, if you like. So therefore the 2 root 6 would go on the top, so 2 root 6. Now, we need to consider if it's positive or negative. Since tan is positive in the third quadrant, cot also must be positive. So guess what? We have just, by knowing that fact, we could have had just a blind stab at it, and we could have got a 1 out of 2 chance of getting the answer because we know it's B or D. But as it turns out, we've done our triangle and we've then shown that the answer is B. Is that fairly straightforward? That's why we use the triangle method. It's just really straightforward. Okay, I'm going to find another question. Okay, so you can see there that I'm just putting that in my calculator. You could go ahead and sketch it. Now, the other method was what Luke was saying, was that he sketched a graph of sine 2x almost in his head. He's then gone ahead and squared it, which means that these negative values become what? They become positive. Okay, so he's looked at, first of all, he's got 4. So he's looking at 1, 2, 3, I think 4 solutions and then doubling it. That's what he was thinking of. But as it turns out, if we sketch that in our CAS, calculator, you can see there that I do solve, x, but be careful, with in 0 to pi is going to tell us our 1, 2, 3, 4, 5, keep going across, 6, 7, 8. So the answer to that question was 8. All right, I'm going to stop there.